Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about DC load line analysis of BJT. Now, as a part of definition, the DC load line of BJT circuit is a straight line drawn on the transistor output characteristic. The load line shows all corresponding levels of IC and VCE that can exist in a particular circuit. So here we are finding the appropriate value or the maximum value from which we get maximum output from this transistor, which is nothing but the collector current IC and its corresponding voltage VCE. So we are getting the very most or advantageous value of these two. We are getting a particular point here from where we can get the maximum outcome of this transistor. This point we are considering at operating point also. So we are finding the operating point with the help of transistor. And why we are finding the operating point? So that we can get the advantageous, what is the maximum advantageous level of this transistor from which we get the best outcome. So we are finding it in DC load line analysis. It is already said that it is done on the output characteristic, so that we are considering here the collector current and the collector emitter voltage. Okay, now this is the circuit of common emitter. We can see that here emitter is common and this is our input side, this is our output side. So we are considering the output side here. In this, if we consider the voltages, this is VCC, which is nothing but the biasing voltage, and here across this resistor RC a voltage drop will develop, which is nothing but the IC/RC. Okay, and here a potential drop, which is nothing but the collector emitter voltage here. Okay, so this is the basic understanding of common emitter circuit we already done in earlier classes. Now this is the output characteristic. We quickly revise what is happening in the output. So this is our horizontal axis and here VCE is there, and this is our vertical axis, IC is there. So IB is fixed. Okay, IB is fixed in a particular manner here 5, 10, 15 and 20. So to draw output characteristic, we have to fix the input values, and here input value we are considering IB, which is base current, and it is fixed in a particular manner. So IB is constant for 5 microampere and we are getting the IC according to that. Similarly, IB is constant for 10 microampere and we are getting the IC according to that. In this graph, one more finding we have done this. If we increase VCE, let's suppose this is 1 volt and this is 2 volt, 3 volt, and if we are increasing the VCE at a particular level, the current will stable after that. Okay, if it is 1 volt, till 1 volt current is IC current is increasing, but after that it is stable. So it is independent of VCE. When it is achieved its maximum value, after that we are increasing the VCE, it doesn't affect the IC. So IC is after a particular attaining a particular value, IC is flowing in a steady manner. So this is our findings of output characteristic of a particular common emitter transistor. Now we will do our analysis here. So as a part of analysis, we have to consider a equation here. So we are considering the KVL or voltage equation in this loop. So here VCC is there. VCC is nothing but the, if we apply KVL, what will happen? It is the addition of collector emitter voltage plus this voltage drop, which is nothing but the IC/RC. So this is our basic equation from which we will get the DC load line analysis. So VCC is nothing but the VCE plus IC/RC, which we consider here in this loop. Okay, now we will discuss the further criteria of this DC load line. We will start with our basic equation, which is nothing but the VCC equal to VCE plus IC/RC. Now in DC analysis, we have to consider the value of IC. So we will consider IC/RC in one side and VCC minus VCE. Okay, these two voltages on another side. So IC is nothing but VCC upon RC minus VCE upon RC. So if I make here, let's say IC equal to, we are considering 1 upon minus 1 upon RC first. So this is VCE plus the second one VCC upon RC. Why we are doing so? Because we have to make a equation of straight line here. DC load line is nothing but a straight line. So what is the equation of straight line? Y is equal to mx plus c. This is the equation of straight line. So in this format, we are making our equation of IC like that. So this is our nothing but the M. So what is the slope? Or M is minus 1 upon RC. Here. So this is the equation of straight line. Here the negative graph is there. Okay, so slope is negative. This is our negative graph. It means it is decreasing in that manner. Or this is positive value and this is negative. Each slope need 2 points so that we can draw the slope properly. So we will find the 2 points. What are the 2 points to draw this straight line? So for better understanding, we will write the basic equation, which is nothing but the VCC equal to VCE plus ICRC. Okay, this is our basic equation. So from this equation, we will get the 2 points, which is nothing but A and B, and we are making the slope. So in horizontal axis, we have VCE, in vertical axis, we have IC. So if we are finding 2 points in a particular manner, we know that 2 points are nothing but the horizontal vertical axis, which is XY. Similarly, for horizontal vertical axis, which is XY. So first, if I find the horizontal value or horizontal point in horizontal axis, what we will do? We will do the vertical x 0. So first condition, if IC equal to 0, it means vertical x is 0. So if IC equal to 0 in this equation, what will happen? VCC is nothing but VCE, because this term will become 0. This ICRC will become 0. So here, this is our first point, which is nothing but the A. When IC equal to 0, so in this line we have find a value which is nothing but VCE is equal to VCC. Okay, so this is our point A somewhere here. Now we will consider our second point. So in this case, if VCE equal to 0, okay, we are making the horizontal axis 0 so that we will find the vertical x. So if VC equal to 0, what will happen? VCC is nothing but the ICRC. Okay, if I am considering IC value here, so IC is nothing but VCC upon RC. So this is our B point. So we find here the point A and B here. Now we will draw the line. So what will be the line? The line will be like that. Here B point and here A point. So this line we will now show in our output characteristic. Okay, so we will show a particular diagram here. This is the diagram of DC load line analysis of transistor. Here we have cutoff region and here we have saturation region. So cutoff region is fully off condition of transistor and saturation region is fully on condition of transistor. We are drawing this DC load line in between that. So this is our active region. Okay. So we are drawing the DC load line analysis in active region. This is our active region in between the saturation and the cutoff region. So what is happening here? We have 2 points A and B, and intersection of this is our Q point. Okay. What is Q point? Q point is the intersection point of IB and the DC load line. So this is our IB. IB is fixed in a particular manner. So all these points are Q points. This is also the intersection of DC load line and IB. This is also the intersection of DC load line and IB. Similarly here, here and here. So we have to find the maximum, middle value of that. So in DC load line, the middle value of all these values, the middle value of that, this is considered as Q point or the best operating point for the transistor. So here Q1, Q2, Q3, so many Q points are there because Q point is nothing but the intersection of DC load line with IB. So here we are finding the maximum value of that, which is nothing but in the center. So this Q is directly depend on base current, which is IB, and the slope. Okay. So why we are finding this Q point? So that at this point we will get the maximum output or the stability of the transistor. So we are getting the maximum output at this Q point, which is nothing but the in between of this DC load line, and Q point is the intersection of IB with the DC load line graph or the slope. So this is the basic analysis of DC load line here. We see that in this we find 2 points A and B, from which we consider our slope here. This slope is negative, which is nothing but the equation of a straight line from earlier studies, and we are doing this DC analysis, so we will get the maximum, a point from which we get the maximum output of the transistor. Okay. And DC load line is drawn in the active region of the transistor, in which the transistor is working in a particular manner. Okay. So this is all about the DC load line of transistor. Now this is much for today. We will study next topic in our next class. Thank you so much.